What is going on, everybody? Welcome to statisticalprogramming.net, or probably just YouTube. I don't think many people actually go to statisticalprogramming.net, but that's okay. Today we're going to be talking about one of the most crucial parts of being a data scientist, and that is getting the data science job. And in order to get a data science job, you have to pass an interview. And so I'm going to be doing a little series right now on data science interview prep, and going to be walking through questions that I myself have asked in data science interviews, questions that I've heard of other people ask, and also just concepts that I think are very, very fundamental for every data scientist to fully understand. So we're going to get started, and the first thing we're going to go through is a machine learning kind of basic walk me through it problem, and I'll highlight all the different things that I think would be very good for you to mention so that you get the interviewer's attention and that they want to make sure they have you there crunching numbers alongside them. But first, let me just give a quick advertisement to easywhiteelephant.com. This is a project of mine that I've been working on, and basically it lets you enter a price and get a bunch of gift ideas, especially for something like a white elephant party. So if you find that interesting, check it out. All right, so what are you going to learn in this presentation, in this video? The most important thing for me is to kind of have a good overall feel of the kind of things you should do in each of these interview scenarios. And so I'm definitely going to try and mention questions that you should ask the interviewer given certain prompts. So as we walk through a basic predictive machine learning problem, what are the questions you should be asking in the early stages? Another thing is the details to give. Sometimes the interviewers leave things open-ended, and you aren't sure if you should give them something very high level so you can keep the interview just moving along. But other times you might just start getting really long-winded as you give them way too many details that they really didn't need to know. So I'm going to try and keep the level of information that I provide as someone who has conducted a fair amount of data science interviews and someone who has gone through one or two. I'm going to try and keep them at the level of detail that I really think is appropriate for each interview question. And of course, how to avoid elimination. I think it's really crucial to have some basic mistakes in the back of your mind so you don't do them. Things like talking about, going down a road you don't really fully understand. That is one that I see get people knocked out all the time. They mention a concept, they kind of are confident about it, but the interviewer then presses them. The interviewer wants to know more details, and they kind of back out. And they're like, "Well, I don't know. Maybe I'd look at that." It's kind of like, "Well, do you even know this concept, or are you just reading articles and spouting out the highlights?" So it's definitely something you want to watch out for. And we're going to try and talk about habits like that you can kind of avoid in each of these scenarios. So I wanted to get started with the interview question that I think is the most common in data science interviews. I do think that nowadays, as the data scientists get more specialized, this is maybe a little more rare, or maybe not more rare. It's definitely extremely still common, but I think this might be a little less prioritized. However, I do think that this is sort of a fundamental. So if you can't nail this, then the rest of the data science interview is probably a moot point. So I do think that everyone should have a very kind of clear concept of how they would address this question before they even think about going for any kind of data science interview. And that includes anywhere from a junior position up to a more senior and so on. And that question is, of course, walk me through solving some predictive problem. A good one I've heard used is a problem to predict people who are not going to return their library books. So people are going to check a book out and end up stealing it. How would you predict that this might be a kind of person who would do that? Other times, I think a lot of times the business will ask you something that's very relevant to their business, because that's the kind of problem that they have thought a lot about. So they have a lot of understanding of the nuances of that problem. And then if you can go in there and you can kind of identify some of them in one sitting, then they're going to look at you and say, this is a person that really is going to be able to contribute right away to our team. So personally, I work at a Fortune 500 company, and personally, that is something that we have used on a data science team, kind of asking them about one of the very, very basic problems in our business and seeing what they come up with. So I'm not going to give you a scenario, but I am going to just kind of walk through a lot of the common responses that would be kind of appropriate if you were asked to walk through a predictive problem. So the first thing you're going to want to describe as you go through your answer is going to be the different phases of the problem. And it's really important for you to know the phases up front so that you can just show that you have a holistic view and understanding of how to approach a machine learning problem. And actually, if you want to, go ahead and comment at the video and kind of describe what you think the phases are, and then that will be a permanent record that you can check back on after the end of the video and say, these are phases that I thought, this is a phase that maybe I missed, or even possibly, and this is very possible, this is a phase that really should have been in there, and James completely missed it. So if that is the case, please point it out to me. I always love hearing that stuff. I'm very, very far from perfect. But these are the kind of the main phases that are very common in data science and machine learning literature. So we have this really, really popular graphic. This goes back a long ways. This is the CRISP cycle. This is, I can't remember what that stands for right now, but the idea is you start with a business understanding of the problem. You look into the data. You go back to the business. You can see the arrow kind of goes back. You say, this is what the data says. This is what might be possible. And then I think once you have some sort of consensus with the business, then you're going to go ahead and get into the data preparation. And we'll definitely go more into depth into these phases later in the video. But as you prepare the data, then you start to try modeling, and then you go back to the data. And I think definitely after you start modeling is when you're going to want to start doing things like feature engineering and other modifications that might be more dependent on the type of model that you're actually using. So then as you sort of iterate with the model and the data, you start to get some good results from the models, and that's when you start evaluation. And in the evaluation phase, you start to really understand, okay, this is what's possible. This is what our, let's say, accuracy is going to be able to deliver for the business. And then you go back to the business and you say, this is sort of where we're at, and maybe we can tweak and we can get some ideas from you on what else needs to be done. So you can see that arrow traces back up to the business. And then, of course, after some period of evaluation, you're ready for deployment, which nowadays is really, really sophisticated and could be a video series in and of itself. But that is kind of the old kind of tradition. If you're going to be walking through interviewers through this problem, I don't think I would exactly try and describe this cycle. To me, it just kind of happens in three phases. So you have the pre-modeling stage, and we saw that when we were talking to the business, and so you definitely need to have the business understanding right away. And then you definitely need to go get the data. So there's definitely going to be some clean, there's going to be some retrieval, there's going to be some summarization. There's a lot you need to do with the data before you even start modeling. But then once you get to the modeling stage, you definitely want to try different models. You want to do things like feature engineering, which I kind of consider part of modeling. And then you also want to do some strong validation. And then finally, there's the post-modeling stage. So at this point, you need to communicate to the business what's been done, what kind of value this is bringing. You also need to communicate to other stakeholders. Some of them are going to be technical. People like software engineers are going to need to help deploy your model. DevOps are going to need to set up an environment. There's a lot of stakeholders involved in pushing out a machine learning model and driving value to the business. And then finally, there's going to be deployment. How involved you are might depend on the size of the organization, but I do think it's fair to assume you'll be somewhat involved in both the deployment and the maintenance of a model in most organizations. So that's kind of how I see the phases. I would love to know if you have a different opinion, if you see sort of the process broken down in different ways. I think that's totally valid, and I would love to hear your thoughts, not just for me, but for other people who are starting to kind of get into data science, people who are prepping for interviews themselves perhaps. For them to see that other perspective would be super, super helpful. So let me know if you have a different set of stages that you think is appropriate. So before getting into all the different stages and how you're going to solve the problem at each stage, it's really important to talk about what are the questions you're going to ask before you even get started. Because at the end of the day, a data scientist should not just be someone who plugs data into a high-level API and gets a really good solution and everyone's happy and claps them on the back. Because at the end of the day, businesses don't really work that way. The person who's asking for the machine learning solution knows less about machine learning in all likelihood than you do as the data scientist. And so you need to fully understand at a high level and also at a detail level, what is their problem, and is machine learning approach the right approach for this solution? And if it is the right approach, are we doing it the right way? Is there anything left that we really need to consider here before we should be jumping into the solution? These are some kind of questions that you could get going with before you start your answer that will kind of show the interviewers, I know what I'm doing because I think at a high level. And when you approach things at a high level, it really inspires confidence that you're going to be able to drive the end result. So for the business, I think one of the most crucial questions is, what does the business consider success? This ensures that you have that in mind the whole time and that your evaluation criteria is going to match really well. There's nothing like putting a bunch of time into a model and then realizing that you kind of solved the wrong problem. And so this, I think, really shows that you're a person who grasps what is needed from a data scientist in the day-to-day kind of business environment. Another good question is, does the model need to be interpretable? If you work in banking and you're doing something like a credit score, a lot of times it's not good enough to say, oh, I can use this black box algorithm to approximate what the model is doing. A lot of times you have to literally be able to say, I'm going to add this weight here and this weight here, and that is how we're going to get our final credit score. For reasons of fairness, for reasons of just being completely transparent to governing bodies. There's times when you won't be able to use certain models because they're just not interpretable enough. And so I think this is a very good question that just kind of shows you have knowledge of the whole arena. And also, what resources can your business provide to help solve this problem? If you start to jump into big data right away and the interviewer hasn't kind of said, we have an environment for you to run Spark, or we have, a bunch of EMR instances that you'll have access to, it can kind of be a red flag that you don't always consider the fact that the business might be constrained in those ways. So this is definitely a good one, again, to show that you have some understanding of what it's like actually in the day-to-day of a business. And then I think really importantly, you always want to sort of clarify what business is available, what data, is available in the very beginning. So how large is the data set? That will obviously change your approach. If it's very big data, you might have some different kind of ways to start than if it's not. And then obviously, how often does data change? Is this a model that you can train once and sort of update regularly, or is this something that is going to need to be maybe kept alive and kept training, retraining itself? In which case, sometimes a simpler solution is better, or even some sort of hybrid where you can have competing models so that you don't kind of get bogged down in one solution. So those are both good. And then also, are there any known data quality issues? Anyone who has had a data science job is probably aware of this. I know coming from sort of the corporate world, I'm very aware of this. This plagues everyone. And again, it sort of just shows that you have a little bit of experience. So those are some good questions to ask. And now you can kind of get into the pre-modeling stage outline. This is how you're going to approach pre-modeling stage. And this is what the the stakeholders can expect from you before you even start the model. So the first thing you're going to want to do is gather data. And you can talk about the difference between owned data and third-party data. And the interviewer should know what you're talking about. Owned data is things like company databases, company web analytics, anything that you can quickly access and you don't have to go to a third party, you don't have to buy, you don't have to get from a government website. Now, so there's also third-party paid data, and this is things like demographic data, geospatial, competitive data. This is stuff that you actually enter into a contract with a vendor and look to buy from them. And then there's third-party public, and this is things like census. There's like data.gov. There's some public data sources out there, which for some problems can actually be a big help. Think about maybe the library problem. If you were to look at census data, if you were to look at characteristics of whatever area you're in, across different libraries, that might kind of really help to help accentuate sort of what's already there in the library's own data. Clean data. So in this case, you're going to want to make some transformations to make the data usable. So if you're using any categorical or ordinal data, you're going to want to encode the data. And there's a lot of kind of out-of-the-box methods. There's a lot of simple APIs to do this. But if you are using big data, you want to keep in mind that feature hashing, making sure that you only have one coding for each categorical variable, it gets a little bit harder in that environment. And then you also want to impute missing values. You can use things like mean or mode, or you might use substitution, or you might get a little bit more fancy with it and use something like multiple imputation. And of course, you're going to want to have a dummy variable for if you have a null value and your data is categorical. And then you also might start off by adjusting for class imbalance. So this isn't always the case. Sometimes you might want to start modeling first and see if the class imbalance has an impact. But if you have something really severe, you might just want to go ahead and start downsampling or upsampling or one of the newer sort of blended techniques before you get going with the model. All right, so next you'll want to look at exploratory analysis. So exploratory analysis can mean a lot of different things, but I think in the highlights, it's sort of the correct level of detail. You want to describe some of the more general techniques that you're going to use. For example, you're going to want to look at the relationship to the target variable. You're going to want to sort of look at the distribution of the independent variables and how they relate to the target variable. You're also going to want to possibly do clustering. It's very useful sometimes to see what variables group together. And you could also do other sorts of dimensionality reduction like PCA if you wanted to sort of avoid the curse of dimensionality. You'll also want to check for collinearity. You'll want to understand which variables are very linear together. Again, if you have tons of variables, it might be good to eliminate them. And if you're building a linear model, you'll absolutely want to avoid that and not use collinear variables together. And lastly, you're just going to want to summarize the data. You're going to want to say, do I have too many missing values? Do I have, what's the range? What's the skew? Is the data sparse? And it really helps. Make sure if you say sparse, don't say a bunch of NA values. That's not what sparse means. Data with a lot of missing values is a lot of data with a lot of NA values. Sparse data is data where more often than not the variable is a zero, and that is so it's sparse to have a sort of record or to have a entry for that record. So an example of that might be, people who have purchased in the last 3 months. And if you're looking at the whole customer base of all time, that's going to be very sparse data. If it's like a purchased in the last 3 months flag, you're going to have very few customers out of the whole group who have done that. And that is a lot different than having missing values. We got some mistakes to avoid. Importantly, name dropping. I mentioned earlier about clustering. Don't mention clustering unless you know exactly how you're going to use it. And then don't mention anything unless you know how you're going to use it. Too many people will kind of back themselves into a corner. They'll start describing a technique, And then as we start to drill down, they don't really know what's going on underneath it. They don't fully understand what they're doing. And as an interviewer, you're saying, well, how can I trust this person to pull off the best solution to my problem if they are comfortable with having a high-level understanding of something and then going out and using it? So just be very, very, very careful that you really understand the fundamentals of anything that you're talking about. And then going out of order, for me, this more speaks to inexperience than it does to the lack of knowledge. But if you start to put something like feature engineering, if you start getting into that far before the modeling, if you're like, first I'm going to clean the data, then I'm going to make some cool features, that tells me that maybe you haven't had experience where certain types of models do better with different features. And other facts like certain types of models, you don't have to impute NAs. Certain types of models are hit worse by dimensionality. So if you think you're going to do all the data in one phase and then all the modeling in another phase, and it's not going to be iterative, that's sort of a red flag to me as well. So just be careful that you really understand that it's an iterative process, and make sure you don't back yourself into any corners. So for the modeling stage, I think the modeling stage is one of the easiest to talk about because likely if you're taking a data science interview, you've probably done some modeling yourself, and you probably have at least a decent idea of how to approach it. So I think I'll just kind of keep it high level. Obviously, when you're trying algorithms, avoid the shotgun approach. Don't say I would try every algorithm, then start listing all the algorithms that you know. But then also, don't just say, I would try one algorithm because I know it and leave it at that. Normally you want to say I would try a variety of algorithms and I would look for them that had this characteristics. For example, you might use neural networks and XGBoost data to approach something that you think has a nonlinear relationship with its variables and its independent variables. So make sure you at least have some sort of reason to back up why you're trying the algorithms that you're going to be trying. And then understand the complexity trade-off. You can understand the curse of dimensionality, and of course just understand that some algorithms are going to take way longer to train, take way more resources in compute power, and be less interpretable often. So make sure you understand that and keep that in mind in the business context as well. The interpretability, we mentioned that in the question to ask. Just make sure that you understand how relevant that is to the particular problem. And then engineering features. So engineering is definitely, to me, feature engineering is definitely part of the modeling phase. But to do it, you are going to have to do a little bit of research on the problem. So in that library example, maybe you can talk to librarians and you can mention how you'd ask them about common characteristics of people who don't return books on time. And then you can see kind of how those are relevant, where you might be able to identify those in the data. And then obviously you could look at other research that's been done to similar problems and kind of make inferences from that. And of course, iterate. So feature engineering is not a one and done. A lot of times features aren't good. And other times you only think of a feature after you've sort of done some modeling and worked out, the concepts and worked out how things are responding. And maybe if you see a certain class of features doing really well, it'll give you some ideas for other features to create as well. So it's definitely iterative. And dimensionality reduction is not a surefire model improvement. There's a million good reasons to use dimensionality reduction, something like PCA, but just talking about how it's going to help my accuracy and it's going to make everything better. In the library example, you might only have 20 data points on each person. I mean, there's not a lot of information that they know about people who check out books, and maybe you can engineer 10, 15 more. But at the end of the day, you might not be hit by that much curse of dimensionality. So at the end of the day, you might want all those features. They might all be not very linear. And so you really probably don't even need to reduce the dimensions at all. So just be careful of that. And again, it just comes down to knowing the fundamentals before you start talking about something. And of course, you're going to want to pick your success metric. And I guess I should have put this at the front because you want to do that before you start modeling anything. You want to know what you need, and you want to know why you need it. And that kind of gets into the precision and recall and F1 scores if you're talking about classification. So different scores make sense for different business needs. It all comes back to that having the business need in mind as you're making the model. And you definitely don't want to get down a road where you've started to model, you've started to put a lot of work into using resources to train your model, and then all of a sudden you're solving the wrong problem and you have to start over from step one. So make sure that you talk about that success metric early and make sure you sort of hone in on what it's going to be before you start to iterate with your model. Of course, there's also the effective class imbalance. So that has to be kind of taken into consideration in your success metric. And obviously, if you're using a count model or maybe something continuous that you have to approximate with a count model or regression, then you have a completely different set of evaluations. And frankly, I don't like using these in interviews because I think they're a lot harder to sort of score. A classification, an accuracy is very intuitive. Even a precision or recall skill, pretty understandable. But something like a MAPE is very, very, very hard to go back to other people and say, well, this is a good score, but this isn't. So if for that reason, I don't think it's a very good interview example, but be aware that these exist and how you might use them if these situations came up. So there's a lot to modeling, and so I wasn't able to fit it all in one slide. But another thing you're going to want to talk about in this stage is testing and evaluation. You'll notice on the CRISP cycle description, the testing and evaluation phase was outside of the modeling phase. And I personally don't really see how that's possible because, you don't model and then look at the test data and then you're done. You absolutely, it's completely iterative. You should always be split into training and testing sets, and you're really not going to get good results if you don't iterate. So you want to describe this in the modeling stage and how you split into test and train. Any kind of split is fine. Obviously beware of leakage. Make sure that you don't split temporal variables or temporal data into in such a way that you're actually mixing up time periods, and that just wouldn't be good. But if it's large, you can take a training sample, and a good way to kind of track that is to start with a model on the full data set or on a pretty good size sample, and then loop through with that same model on different data sizes and kind of see what results you get for training on different sizes. And I mentioned it earlier, watch for leakage. This is a good one, again, to kind of pick out experience in people. If they really understand that the only data you're going to have is data that's going to be available in production. Temporal, time series, time-based data is where this comes into account most frequently, but there's a lot of different situations where data could change, but from the time that you have it sort of cleaned up and nice in your modeling environment and compared to the data that's actually going to hit your system for production. So just be very, very aware of that. And if you can mention that to the interviewer, I think you'll definitely score some points. And then obviously in your testing and evaluation, understand bias variance trade-off. I think most data scientists, you kind of get that through your head really, really quickly, but understand why the trade-off exists and be able to talk about that with your interviewers. And then there's parameter tuning. Parameter tuning is usually at the phase where you've narrowed down the models or the model types that you're going to use to maybe several or maybe even just one. But the first thing I would advise is to describe to the interviewers that you're going to learn, or maybe you already know, all the parameters that are relevant to that model. Obviously, grid search, Bayesian optimization is great, but a lot of times it really helps to have sort of a craftsman's approach to tweaking different things and seeing where the results are. And in order to tweak things well, you have to really understand what the parameters mean and how they're affecting the model. But that said, it's totally okay. It's very, very good, actually, if you say, I'm also going to throw my parameters into grid search and see if I can get some improvement that way. and then when to stop. And this, I think, really it comes out of knowing about the business data science experience. Because in the end of the day, it's very hard to know, other than having a deadline, it's very hard to know when is this model good enough to be put into production. And my idea of that is that it's normally good enough to be put into production when the stopping criteria is tied to the business value that's being driven. So does the accuracy allow for the implementation to be profitable? And obviously there's always resource constraints, but this is normally a good target to have. If I can get the filter to this sort of accuracy, or if I can get the prediction to be this correct, then I can expect profits of Y, and that's why I should be able to stop and start to put this thing into production. And of course, as you're wrapping up a model, you need to be able to take steps for further improvement. So this includes things like documenting, logging all your results, and of course saving your model somewhere. I think nowadays there are some packages that will literally save your model, sort of like a GitHub for model development, model holding, model versioning even. And you'll want to mention these kinds of things and be familiar with them as you go through the interview. Documentation is just one of those, like, yes, I've been there type of things. In the corporate world, it's very hard. There's deadlines, people are moving fast, and so much work gets lost, and there's actually so much productivity lost because you're redoing things that other people did. So if you come into a corporate environment and you mention documentation, it's going to be music to everyone's ears to know that you already are thinking about that. So now some modeling mistakes to avoid. It's important not to name drop. I keep just really crushing this point, but I've seen it too many times. Don't automatically assume PCA is going to improve your accuracy, and just don't name drop. Just understand the fundamentals. I think I've beat that enough. Going out of order. So you want to make sure that you have your success metric figured out before you get going with a model. And I think you want to make sure you call that out to the interviewers so they know that you really understand the process. And then you want to make sure that you pick or narrow down the algorithms before parameter tuning. This is probably a little bit debatable, but maybe you could start running grid search right away, or if you're already really familiar, you could start parameter tuning before you kind of narrow down what algorithms you're going to use. But in my experience, I think, in my personal opinion, you don't want to get too bogged down sort of doing a local optimization if there could be better models out there. So that's my opinion. And then obviously, avoid being too narrow or too broad. Like, don't say you're going to try every algorithm that exists. Don't say you're going to read 100 research papers. You want to be able to strategically pick where you're going to put your resources and still kind of get things done on time. And then obviously the opposite of that is don't be married to one approach. Don't walk in and say, I got a top score on Kaggle with XGBoost, and so that's what I'm going to use here, and it's going to solve all your problems. People, the reason the data scientists command so much money, and the reason why it's so in demand, is because there's no one-stop solution to everything. There's no free lunch. There's even a no free lunch theorem that talks about optimization, but it's totally true. There's just always something different about every problem. And so don't be completely married to one approach as you go through it. And finally, and this is sort of me riffing a little bit, but it's okay to use all the variables in a model. A lot of people start talking about feature elimination. And if you have a lot of overfitting, if you have a lot of features, that's probably going to be a good idea. But it's not always a good idea. It's not always necessary. Sometimes you can just have all the features, and sometimes the data set's already prepared for you in a way that you can use all the variables. So whenever I see a candidate being too rigid and saying, I need to get rid of these, I need to start eliminating features, it's like, well, did you even ask if these problems exist before you started doing that, or did you just assume you would have to? So just be cognizant of that and be a little bit subtle in how you talk about getting rid of variables. And then lastly, it's understanding why less is usually better. Understand the curse of dimensionality. I am hoping to do a future video on it, but basically be ready to explain why less is more, and why you're going to be getting rid of those features. So as you go through the post-modeling stage, you just want to be able to finish strong, and you want to describe some things you're going to do as you finish up the modeling process. So the first thing that I would always talk about is communication. So make sure that you understand that you're not just going to be talking to fellow data science stakeholders. The job of a current data scientist is to solve problems for the business. And you do that through your knowledge of machine learning and through your knowledge of all the different techniques that you could possibly use to turn data into something very, very valuable. But that means that you're not just a guy who builds something and walks away. You're someone who has to have really, really, really good skills at delivering the message of what you just did to your audience. And that means that one of the first things that you should really be talking about is how you're going to communicate. And so I like to say, match the message in the audience. Describe the different levels of details for different stakeholders out there. If you're talking to an executive, they don't need to know every little bit of detail on how you built the model. But if you're talking to someone who's going to go implement it, then that's going to be a completely different scenario. So just make sure that you know enough about communication to be cognizant of that necessity. And then describe the business impact quantitatively. Never assume that because people aren't data scientists that they aren't quantitative. I think in most cases, and certainly in my kind of corporate world experience, the rest of the business is maybe ignorant of how to create a model in Python, but extremely, extremely knowledgeable of how to understand a financial model. So you want to be able to really describe that my model is going to drive X revenue. It's going to, maybe have a margin of Y, and maybe if everything goes wrong, you have a possible cost exposure here of all the resources and time that's been put into it. If you can really describe that in a good way, I think you're off to a really, really, really good start with being able to show that you can communicate properly. And then there's also going to be deployment. And deployment is, again, depends on your organization if the data scientist is going to be extremely involved here or just sort of an advisor. But this is something that you do need to mention because it is part of the data science process. So you need to know, is training going to be needed in production or just inference? You probably should have known that in the beginning. I think we had a question about that earlier. But you want to be able to discuss the trade-offs and discuss what kind of options you have if you have different solutions. And to discuss those options, you're going to want to understand production architecture. So if you have to train data, you might want to have something like training as a service, where the training sits behind an API. People can hit that API. They can wait for a while, get trained data back. Or they can, maybe there's something streaming and it's constantly training with streaming, or maybe there's batch updates. Likewise for inference, maybe inference is something that's really, really simple, and maybe you could even in some cases have inference done in a database. You could have it done on a page, or maybe behind a service as well. Then there's also these third-party options, so something like datascience.com or AWS SageMaker, for example. If you can at least talk about the different kinds of production architecture out there, that's going to really, really help you. And I would definitely suggest before you take a data science interview to sort of Google around, make sure you're comfortable with that, because people can be experts on Kaggle, but at the end of the day, not have any understanding of how to deploy a model in the real world. In the business environment, production is like 9/10 of the law. It's like it's what really, really, really matters. If I can create a model that's 75% accurate and doesn't break and doesn't cause a lot of problems by going down all the time or by needing a ton of maintenance, that could have a lot more value than getting something to 79% accuracy that constantly has to be swapped in and out, that constantly is going down. So if you can understand that, if you can describe that to the business, you'll be in really, really good shape, and I think you'll really make a good impression with your interviewers. And then there's maintenance. So the maintenance of the model is a little bit different deployment in that it's usually a data scientist's job to go through and continue to track the accuracy over time. So you want to do something like have quality checks, maybe even just run tests and just keep on seeing what your solutions are. And of course, you might be wanting to refresh the data, the models over time. You might even want to change the models, and you can do that with competing models. So a lot of times companies will schedule these reevaluations where they'll try out a few other models. Maybe they'll have a new data scientist come in, see if they can do better, see if they can put in a different approach, and get that continuous improvement. And since you're all teammates, it's not a competitive thing in like a zero-sum game. It's a everybody wins thing because the models are getting better and you're all contributing your part into making this a reality. So competing models are a great thing to kind of bring up when you're talking about maintenance, as well as just tracking the accuracy and sort of the more normal things. So we get to some final advice, and thanks for sticking with me. I hope this has been valuable. If there's anything I could do differently, if you'd like to see more visuals, if you don't like the format, I'd love to hear about it. Please leave me a comment, and I promise I will take them to heart. Just some things to really address. I've said this probably 20 times so far in this video, but avoid unknown roads. Data science is such a broad field. It's okay not to know everything, but the worst thing you can do is, act like you know something when you don't. Because then everyone is skeptical about what you do know. And so even if you do really know a subject, if you've already kind of shown that you'll act confidently about something that you don't know about, people really don't know when to trust you and when not. So just really avoid going down unknown roads where you don't understand the topic. And then, really first and foremost, keep the business purpose and the business function at the forefront. Kaggle is great. Kaggle is... for anyone who doesn't know, is a place for people to compete online in data science problems. And it's very, very useful for building sort of fundamental knowledge and how to develop and especially tune models for data science. But Kaggle is not really the full business experience. It's not completely the same as having a professional data science career. And that's because professional data scientists have to drive value. Otherwise, at some point, you will be shown the door. So make sure that you can describe to your interviewers how you're going to keep the business purpose, the business value at the forefront of your mind the entire time, and make sure they really know that and they really get that from you. And lastly, begin with production in mind. So as you're making choices, as you're walking through the interviewers, as you're walking with the interviewers through the problem, make sure that they know that you're already thinking about how this thing's going to be used in the end. Because the real value out of a data science model is in what it can do over the long term. And that really means that you're going to have something that can be viable. It won't need constant it'll need some upkeep, but it won't need to be constantly looked at. It won't need a lot of human intervention. And so really understand production options and keep that in mind as you're walking through every single stage of your answer. I hope this has been valuable. I hope it's been fun, maybe. I don't know. But I hope that overall you liked it. If you have any suggestions for improvement, please let me know because I will be making more videos in this series. Next up, I think we're going to be talking about how to prevent overfitting, which again is one of those just really classic problems, classic interview problems. So we'll get to that next. I really appreciate you sticking with me. Let me know how I can improve. Have a great day.